Hello and good afternoon, everyone. I apologize, I prepared my presentation in English since this is International Congress and we have some international guests here. My name is Nikolina Pivac. I am a PhD student at the Faculty of Electrical Engineering, Mechanical Engineering and Naval Architecture in Split. I'm happy to be here today in Belgrade and to talk about the field research I did under the supervision of my professor and mentor Sandro NIŽETIĆ and Agis Papadopoulos, with the equipment provided by HEPESCO, a Croatian publicly owned company that finances energy-related projects on a commercial basis. Okay, so to begin with, thermal comfort is occupant satisfaction with the surrounding thermal conditions. It affects occupant behavior, like if we are feeling cold. Now we will, in our office, we will turn on the heating device or put on the jacket and scarf. And that is why it is important to keep our working environment pleasant. In that way, it will lower the energy consumption and it will affect health of the workers and their productivity, because they can remain focused on the work they do. So in the end, it will rise the company's income. And how we will do that? By occupant behavior and thermal comfort modeling. There are several models of thermal comfort and not so many about occupant behavior, and this is what I do for my PhD research. So this case study I did at the Faculty of Electrical Engineering, Mechanical Engineering and Naval Architecture. When we did that, we had three objectives in our mind. To investigate the occupant's behavior influences how it influences the energy performance, to determine the dominant parameters which are affecting the occupant's behavior, and to determine the dominant factors which are affecting the occupant's satisfaction with the thermal surroundings. So this case study was divided into two main parts. First, we measured air temperature, relative humidity, and the level of CO2 in office rooms. There were 22 randomly selected rooms for this study. We used this device, Chemo AMI 300, and we also monitored human behavior by giving people this survey questionnaire about energy consumption self-assessment to fill out. This is the brief overview of the respondents. So 35 people participated in the study, all between ages of 25 and 62. There were more women than men, between 0 and 43 years of employment. Some of them were smokers, most of them not, and 50% of them share an office and 50 did not. So these are the results of measured values of air temperature. In this diagram we can see the average indoor air temperature during the day in comparison to the outdoor temperature. This straight line represents the outdoor temperature at 9 o'clock, at 12 o'clock and 3 o'clock in the afternoon. And this bumpy line represents the indoor air temperature between different rooms. These are 22 rooms. So in the morning the average indoor air temperature was 22.7 degrees Celsius with the variation of almost 3 degrees. At 12 o'clock the average indoor air temperature was 24 degrees Celsius with the variation over 4 degrees Celsius, and in the afternoon the indoor air temperature was 24 0.3 with the variation of 3 degrees Celsius. And as we can see, the influence of the occupants is significant. We also, like I said before, measure the level of relative humidity. So we can see also these variations between the rooms, but they're all in the range from 40 to 50% as recommended by OSHA standard. And this, in this diagram we can see big variations in average level of CO2. In the afternoon it is from less than 400 to more than 1,000 ppms, so it reveals a big influence of the occupant, possibly in form of window and door opening, but this is something that needs to be further investigated. In the next 2 slides I will show these tables that determine the factors that affect occupant behavior. So in this particular table we can see that there is no statistically significant difference in energy consumption between male and female employees at the FESB. And occupant behavior partially depends on office sharing, meaning that most of people who share an office usually turn the computer off at the end of the working day and switch off the lights when leaving the room. But the energy consumption awareness is very low at the community level of FESB employees. Hence, the leaving for the lunch break without turning the computer off is a part of daily routine and collective behavior, and as well as not reading documents from the computer screen. This table shows that the energy consumption does not depend on whether the person is smoker or not. The behavior does not depend on whether the person is smoker or not. And this is the linear correlation. I use the IBM SPSS statistical program to determine the factors that affect occupants' satisfaction with the thermal environment. And we can see from this table that occupant sensation is influenced with the lighting in the room, indoor air temperature, and indoor air quality. These 3, meaning that their satisfaction will increase if the values of these variables increase. And the last test I used was rank correlation, and this coefficient here shows us that the occupant satisfaction depend on more women than men are feeling satisfied with the conditions of the room they work in, and we can see negative correlation between office sharing and the satisfaction, meaning that people are mostly more satisfied if they do not share an office, maybe because they are in full control of comfort conditions in the room. So for the conclusion, so the indoor environmental parameters are within the values recommended by standards. Variations prove that the impact of the occupants is significant. There is no statistical difference according to this study in behavior between male and female users, smokers and non-smokers, and people who share an office in comparison with those who don't. Factors which clearly affect the occupant satisfaction are lighting in the room, indoor air temperature, and air quality. And further research will be based on the quantification of the influence of the user. And that is all from me. Thank you for your attention.
Thank you.